Sometimes you are required to convert a complex number from rectangular form to the polar form because the polar form might be more useful than the rectangular form, or vice versa. This is what I'm going to explain in this video: how you convert a complex number from the rectangular form to the polar form, or from the polar form to the rectangular form. What I have on the right hand side here, this is what we call the rectangular form. This is the rectangular form. In the rectangular form, A and B are constants. A being the constant representing the magnitude of the real part of the complex number, and B is the constant representing the magnitude of the imaginary parts of the complex number. That is the rectangular form. On the right hand side here, I have what we call the polar form. There are different versions of expressing the polar form, and I'm going to mention them later on. This is the polar form. In the polar form, you have R, and R is called the modulus of the complex number. That is the modulus of the complex number. And theta, this theta here, theta is called the argument. It is an angle. It is called the argument of the complex number. So if you are converting from the rectangular form to the polar form, you are simply finding R and theta. You just have to find R, the modulus, and theta, the argument. I'm going to explain how you do this. I'm going to start with converting from a rectangular form to polar form. So rectangular to polar form. Rectangular to polar. An example is, I'm given, let's say 2 minus 3i. So we have a complex number called z, which is 2 minus 3i. And we are required to convert to polar form. We want to convert this to polar form. Convert to polar form. What I want to do first, I'm going to do a sketch of the Argan diagram of Z. So the Argan diagram, we draw an Argan diagram on a Cartesian plane with the horizontal axis being our real axis. This is the real one. And this is I, the vertical is the imaginary. The real part of our complex number is 2. And the imaginary part is minus 3, which means we are here in the fourth quadrant. We are here where we have a positive 2 here and a negative 3 here. Our argument, theta, it is this angle here. This is our theta, the argument. It is this whole angle. And the modulus, R, it is the length of this line here. This is R. R is the length of this line here. That is R. We find R by applying Pythagoras theorem, because we understand that this one is a right angled triangle with R being the hypotenuse and minus 3, which is our B. Our B is here and our A is here. And so we know that R, the modulus, is the root of A squared plus B squared. In our case, this is the root of 2 squared, which is our A, 2 squared plus B squared, which is minus 3 squared. We get our R. So this is the root of 9 plus 4, which is the root of 9, 3 squared is 9 plus 4, that is the root of 13. So root 13 is our R. We have our R. Done. Then we have to find now the argument theta. But what we find from our calculator, this is very key. We find theta ref, what we call the reference angle. And from our diagram, the reference angle is actually this angle here. Let me use a different pen. Let me use blue. This is our theta ref. This is what we can get from our calculator, theta ref. To get the whole angle, this whole angle here, theta, we're going to say 360 minus theta ref. This is what gives us theta, because theta is an angle that is above 270 degrees, but it is less than 360 degrees. This is how we find. So let us get our theta ref, which is what we get from our calculator. If we're in the first quadrant, the theta ref is actually the theta. Now theta ref is the arctan of B over A. And our B, in this case, it is minus 3. But we don't care about the sign of that B. We just use 3. So it is 3 over 2. I mean, this is the arctan of 3 over 2. So this is the arctan of 3 over 2. Don't worry about the sign of your A and your B. Just use positive numbers. If we do that, we have the arctan. I'm going to get my theta in degrees. So if you want to get your theta in degrees, you make sure your calculator is in the degree mode. If you want to get your theta in radians, you make sure that your calculator is also in the radian mode. So arctan of 3 over 2, I get theta ref is 56.310. It's 56,310,310 degrees to 3 decimal places. From here, I can conclude that therefore theta, the argument now, it is 360 degrees minus 56.310. That is my argument, because the argument in this case is actually a reflex angle. So we have 360 minus 56.310. I get 303.69 degrees. So I have my theta, which is my argument. I have my modulus. It means I can now write the polar form of my. Okay, this means, therefore, we can conclude that Z, which is 2 minus 3i. This is the rectangular form. This is our rectangular form. Rectangular. The polar form will be Z R CIS or cis theta, which is root of 13 cis theta, which is 303.69 degrees. This is correct. You can still express it in this format again. All these formats, please know these formats, all of them. This is the root of, you can say this is root 13, root 13. You draw something like an angle here, and you write the 303 here, 3.69 degrees. This is another way of expressing a complex number in polar form, or you can expand what this is standing for. This is standing for r cos theta plus ri sin theta. That is what it is standing for. So you can say this is the root of 13 cos our theta, which is 303.69 degrees, plus r, which is root 13, times I. You can write the I here before if you want, or you write it after. Doesn't matter, because it is multiplication. So root 13, here we have sine 303.69 degrees. All these three, these are the three forms, or the three ways in which you can express your complex number in polar form. The last version, this one here, this last version is very useful if you want to convert back to rectangular form. So I'm going to use what I have here. This is the polar form. I'm going to use it to convert back to here. I don't want to do many examples. I just want to use this example in forward and backwards. I have used it to convert from rectangular form to polar form. I'm going to use it again to convert from polar form back to rectangular form. We should get the same answer. So let me clear this. All right, I'm going to start by writing it in the way it was. So this is z equals to root of 13 cis 303.69 degrees. This form here is not very useful if you want to convert. So our question is saying convert to rectangular form. The version that we have here is not very friendly when it comes to conversion to rectangular form. Use the other version. So the first thing that you need to do here is to write it in the other version of, so this is like z equals to root of 13 cosine of 303.69 degrees plus I root of 13 sine of 303.69 degrees. All you do from here, you just punch this in your calculator. It gives you A, which is the real part of your complex number in rectangular form, and you punch this in your calculator. It gives you B, which is the imaginary part of your complex number in rectangular form. So all I do, I just take my calculator, punch this. So I'm going to punch this in my calculator. So I have root of 13. If you want to write it into 3 decimal places, you can do that. So I have root of 13 times the cosine of 303.69 degrees. I get here 1.99996 plus I punch the other part, which is now root of 13 sine of 303.69 degrees, close the bracket. I get minus, so this is minus 3.00000. I have an I there. I just wrote too many decimal places here just to highlight the answer that I'm getting from my calculator. But if I'm going to round off to the standard that we are required to round off to 3 decimal places, or if I say to 3 decimal places or to whole numbers, let us say to 3 decimal places. If we try to round off to 3 decimal places, you find that the first part here is just going to be 2.000, so it's just going to be a 2, and plus minus obviously is going to be minus. If we look at this number here, it is essentially a 3, so this is 2 minus 3i. We have gone back to what we had in the beginning. This is z, which is now rectangular. I want this video to be short. I have shown you how you convert a complex number from the rectangular form to the polar form, and also from the polar form back to the rectangular form. Please subscribe to the channel, give a thumbs up to the video. Thank you for watching.